And welcome everybody. It is October 22nd. This is the Konflux Community Architecture Call. Alex, you are up first on the agenda.
Thanks, Ralph. Okay, so let me just preface this whole thing with saying this topic is somewhat related to our downstream use case, but the overall concepts may be relevant to a number of teams for just the community aspect of it all. I'm looking at replacing our use of kubesol for space requests. We have this in a couple places downstream. There's a task which allows users to provision an ephemeral namespace on the Konflux clusters with role bindings, etc. And then we also use it for our environment as a service feature, which is ephemeral OpenShift clusters, basically bridging the gap between clusters because we have a multi-cluster environment there. This topic has kind of been, well, it's definitely relevant because of the recent discussion about workspaces. So seeing as we're going to deprecate those, we absolutely must move away from space requests, but we needed to do this anyway due to other limitations with them. But I've been looking at a proof of concept for using Crossplane to do something like this. I'm sure most of you have probably not seen or looked at Crossplane before, so let me give like the 10,000 foot level. So this is just the general documentation. The interesting thing that I'm looking at for this is that it provides the concept of claims. So what this Crossplane, what it allows you to do is define your own, what they call composite resource definitions. You might say that's a CRD equivalent, but they call it an XRD. And you pair that together with a composition. Think of that like a pipeline, similar to maybe the Tecton pipeline, but they have their own language for declaring this stuff. Declaring those two pieces, as well as declaring a claim that references, or the XRD references the claim, allows the Crossplane system to compose all that together, and it creates a composite resource which manages well, what they call managed resources. Those are deployed on the local cluster where the Crossplane is running, but the way that this works is that there's Crossplane is very pluggable, so there's providers, functions, and some other things like environments. Not using environments yet, but they allow you to optionally plug in different providers. For this particular case, and I'm going to give you a little bit of a demo, I'm using the Kubernetes provider to access a remote cluster to provision an ephemeral namespace there using a claim. And let me jump over now to my actual demo. Second. All right, so I've linked the repo that I'm showing here on the Google Doc. I'm not going to go through all these steps. Of course, there's a bit of installation. It's really just installing through Helm. There's also a little bit of setup. Again, all this stuff is pre-configured in my setup here. Some of the interesting things are the provider configs, the XRDs, and composition. Taking a look at the provider config. So this is, as I mentioned, I'm using a Kubernetes provider here. We're referencing a secret. So in this case, I'm calling it the EAS cluster because that's what we have downstream. And there's a kube config in the secret. And I have a reference to the cluster API right there. Here is the composite resource definition for a namespace. You'll notice that the kind starts with an X. That's kind of like a typical pattern you see with Crossplane, X something, and then the claim name would be just that something. So in this case, I've got a namespace object. Of course, this is not just to avoid overlap with the default namespace definition. Of course, it's in a different group. All this is not finalized, of course, it's just a proof of concept. So don't pay too much attention to the group. This is a very simple XRD. There's really no additional spec in here or status, but you can pretty much customize this like you would any CRD. The next kind of most interesting part of this is the composition. So this is where everything actually happens. So this looks kind of like a tecton pipeline. You'll notice that there's even a mode for pipeline here. But I won't go through all the details here, but the general steps are: we create a namespace, we create a service account, create the service account secret, and create connection details. Connection details being a secret pulled back into the current local namespace where the claim is created, and it will include the keys for all these different sensitive details. So one of the interesting things, actually, I will go over here, is that we're building a kubeconfig on the fly in here. So there's no actual code here. It's just all done with Go templating and just this pipeline definition. But we're able to compose this kubeconfig and have Crossplane copy it over for us. Taking a look at the actual claim, it's really pretty simple. We just basically say we'd like a namespace, and we'd like to write the secrets of that namespace out to secret by this name. So I'm going to run a demo script just to show you what it does. It's pretty simple, just doing a bit of cleanup here. Going to create the claim, and then from there, I'm going to just take a look at the status of that claim, wait for it to be ready, take a look at it again, and then access the current secret, or take a look at the secrets that are in my current namespace. And then I'll write that out to a kubeconfig, use that kubeconfig to access that remote namespace, getting a few things here: service account secrets, findings, etc. So let me go ahead and run that. So got these steps right here. So you can see I'm currently on, so I have 2 clusters here. The current one I'm using is behind the Red Hat VPN, just to make this more realistic of what we're trying to do. We're trying to get a cluster behind the VPN talking to a public cluster. So from here, I'm going to run this script. It's creating the claim. I'll walk through the results here. So it created the claim, here. And then we accessed the claim just to check on the status. It's not ready, of course. We waited for it. It only took a second or two. It becomes ready. The connection details are written out to this claim secret, listing the secrets in the current namespace. You can see that my claim secret was created. It's got 5 keys in it, and extracting out the kubeconfig portion, and then using it to access the remote namespace. So you can see that I can see the namespace manager service account that was created for this. There's a token or a secret for it with a token included, and there's also a role binding created for it. We can see I can actually delete that claim now, but this will trigger the deletion of the entire remote namespace, and as well as remove everything within it, and it will of course invalidate the kubeconfig that I've stored on my local disk here. And finally, if I just take a look at the secrets here, you can see that claim secret is also erased. So you no longer have access to this namespace. So this is just, this is kind of the end of the demo. There's really not much more I want to share. I just wanted to kind of put this out there because we're thinking about adopting this, of course, downstream for some of our use cases. But this might be interesting to some other teams. We can kind of create different XRDs without really creating like an entire controller to back it up. So I guess at this point, any questions, or maybe there's other people who've looked into Crossplane and have any thoughts about it?
Alex, that was super cool. I'll raise my hand just to get on the stack. I have a couple questions. The first one is, how does the composition get linked into the XRD or into the composite resource? I missed that part. Like I saw the composite when you created the X namespace, or it was just namespace. There was no mention of the composition.
Yes. Let's see. That is, sorry, there is, I think it's in the composition itself. Just refreshing my memory here. Yeah, there's a composite type ref right here, which points to the XRD.
Interesting. Does anything like reasonable happen if you have two different compositions with which both link to the same XRD?
I have not tried that. That would be an interesting use case. I imagine both might actually kick in.
Yeah, maybe you want that. I don't know if it's a good thing or a bad thing. I'm just trying to figure out how it works. Thank you. I think Brian's hand. I'll raise again after that.
I missed the beginning of the demo and joined a little late. I just wanted to know, for our use case, does this mean that we will be able to not run the second cluster, or do we still need it?
We still need the second cluster.
Okay.
For our environment as a service stuff, we're deploying control planes there. So we need that to scale, and we don't want to, of course, bring down the performance of the Konflux clusters.
Got it. That makes sense. Thanks.
Yeah. There's a lot of interesting stuff we can actually do related to that. For instance, we can create new XRDs that represent everything on the remote cluster. So today we allow users to access a namespace on that cluster and then create what's called a cluster template instance. But we could maybe cut out a lot of that kind of like leaky abstraction that we've got there and just have like an abstract sort of XRD that is meant to represent the remote cluster that is being requested. Ralph?
So how did the delete work? When you deleted the namespace, the composite resource namespace, it cleaned up the secret. Did it also clean up the namespace on the remote cluster?
It did, yes.
And how did it
Didn't
do
explicitly show that.
a separate pipeline for taking those like concrete delete steps, or was there?
So the way that this works is the composition has, well, it creates a bunch of managed resources. So these, in this case, are managed by the Kubernetes provider. So there's a separate controller that reconciles these things, and it looks for objects, as you see here. And if the claim is deleted, then the resulting objects within here get deleted, and the controller will recognize those deletions and remove the remote resources.
Interesting. Okay.
Yeah. So one downside that I could maybe see to this whole system is that, of course, for every remote resource that you declare within a composition, you are creating a local resource that mirrors that in some way. It is provider specific, so some providers might require fewer local resources for that. But in the case of the Kubernetes provider, you're going to have a bunch of these objects, but they're just references to the remote objects on the other cluster.
Yeah. In some ways, that's good because it's explicit. You can track them on the control cluster.
Yeah.
Cool. And then last question is, how did the composition pipeline, and maybe this is just a detail of the Kubernetes provider in Crossplane, but how did the composition pipeline get rights to create namespaces on the remote cluster in the first place? Did you have to configure a kube config to give to Crossplane at the cluster level?
Yeah, so that's provided here in the provider config. There's a set of credentials, so it's just a secret on the local cluster. And I had to just provide an annotation so that it could understand how to reach that cluster.
Gotcha.
But,
The remote cluster.
Yeah.
Okay.
Yeah. Now there's other providers too. So I know there's certainly like some of the cloud providers like AWS, Azure, etc. So there's maybe a bunch of opportunities here for us to create XRDs that represent remote cloud resources if we need. So I'm thinking maybe like NPC or I don't know, maybe something else. But it's something maybe worth investigating by other teams.
Awesome. Thank you.
Yeah. So this is something we're considering implementing downstream. So you might see a Crossplane component show up, and we'll probably just start with experimenting with the environment as a service use cases, but maybe we can expand on it later.
That's cool. Thanks so much, Alex. Awesome demo.
Yeah. All right. Thanks, everyone.
Next up, second point on the agenda, Yuri, are you on today?
Yes, I'm here, everyone. Hello.
Hey.
So, if I can bring the situation that I got myself into today. So, we got reported that some task from the build definition is failing. Those would be Claire and the Clem AV. So I started investigating what is going on. I ask for the access to the workspace so I can see more things. And it turned out that the product or the build image that is being created is unusually large. So I suggested to the customer to scale it down a bit, because all his builds were stuck in the last phase, that is the SBO, right? It was just stuck there for eternity. All his builds, it was there for over 100 hours. And he pointed out that within that Tecton folder, his pipeline run has set the task run spec limits. And to be exact, the memory was 10 gigabytes. So my question is written actually in the document. So how do we want to, or how can we handle the case where customers are over exceeding those quotas? Obviously, we are not failing anything. We're just spinning the build run to the eternity, and jobs are failing because of it, or tasks. Is there any official limit for the Konflux images that is like the ceiling, the top of the scale of the image that we are allowing them to build, or if there is not, is it documented someplace, or do we need to document it someplace? That would be my question.
Yuri, can I try to ask some questions to clarify? That
Yes.
there's two quota things in place. One is a resource quota at the namespace level that limits the total amount of CPU and memory and the number of certain resources that can exist in the namespace. And then another is the requests and limits on pods in the pipeline.
That's right. Yes.
So is the issue that the user, they knew how to tune up the requests and limits on their pipeline tasks, so they increase them up high enough such that then the scheduler wouldn't schedule their pod, because if it did, it would exceed the resource quota at the namespace level. Does that sound like the problem, or do I misunderstand it?
Actually, so you're saying if they're it's set natively, the number of what they are allowed to, right? Or they can play with that. They can extend it. They can modify it to.
Yeah. There's two different limits. There's the namespace limit, the resource quota, which they don't have direct control over in their namespace. And so it's kind of a hard limit. I'll come back to that in a second though. But then there's at their pipeline level, they do have the ability to specify requests and limits differently on their tasks. So if they know they want to request more memory for Claire to run or increase the limit for Claire to run, they can do that in their own private pipeline definition as a user. And there's nothing about the system that should stop them from doing that. I think we have a user-facing doc too explaining how to do it. So it's a supported kind of thing. But if they were to increase that super, super high, at some point they're going to go beyond what their namespace resource quota is. And at that point, I think they would see a similar kind of failure to what you're describing, where the pipeline run would run to a certain point, but then the scheduler would refuse to schedule the pod because it would go beyond the quota of their namespace.
Yes, I think that's what's going on. That's what's happening. So the next time this happens, I suppose the customer will adjust the scale of their image. So the first step would be.
Well, can I jump in here with one other thing? So I said before that the resource quota is kind of a fixed thing, but it's only kind of a fixed thing. They don't have direct access to control it. But with our current implementation downstream, we're using kubectl for managing that resource quota, and we have different tiers that we can move the user into, so they can escalate to the infrastructure or platform team downstream and ask to be moved into a higher tier. I think that's an option for them.
Okay, yeah. So yeah, it depends, and so that brings the following question. I would say, like, what is the limit where, like, this is in a case, let's say their images is just a little bit off, it's just a little bit above what their requests are or for compute resources, but if it's 3 times that, I would say I would advise to ask first, why is the image that large, and then if it's possible to scale it down, right? Because I'm just looking for the solution to let them know that, okay, this is not ideal, right? So we don't want to build immensely huge images like on daily basis.
Yeah, I think that's right. I think we've got to have how should I say this? I think we've got to have the capability to build immensely large images. Like our system needs to be able to handle that. But we can advise the user to say, if you can figure out a way to make this image smaller, you're probably going to have a better experience end to end. Because every time we have to push and pull that image between Quay and the cluster is going to be time that they're going to spend waiting for their pipeline to do essentially not valuable stuff.
Yes, exactly. Actually, the first question from the customer was, how can we lower the time for this image to build, or for the build pipeline? And the obvious answer was like, scale down the image, right?
Yeah.
Okay.
Yeah, but that said, that 35 gigs I saw in sidebar comment, I know we're building other images that are twice as large as that. So there's
Jesus. Okay.
our theoretical limit is higher than even that. But like the user, I think your advice to the user on user experience is correct. However, just expect there's going to be some user that's going to need to build a completely ridiculously large image, and
Okay. Yeah.
support for
Yes, Greg.
Yes.
Did they need
Right.
5 gigs of memory to run a scan task? Was that? Maybe we don't know. That's okay.
All right. Okay. So, however, if I go back a few sentences, do we have any documentation on it, or is it someplace written to point it out to customers, like, okay, this is what we what you can use?
I think we have written documentation on how to tune the requests and limits at the pipeline level, and I don't know about documentation for advice on how big of an image is too big.
Yeah. This is like the first occurrence of this case. So if this is getting more frequent, I would say it would be good to have some form of a place to show them, to guide them through.
Andrew?
To be precise, I think that it's not a size limitation of an image by Konflux. It's a size limitation by a specific or for a specific task. It depends on what the task is performing, and it depends on whatever is surrounding that processing. If it needs to do something which needs too many resources, or which isn't performant within a reasonable time frame of some pipeline, then that should be a call out that's done for that specific task and not for Konflux generally. Because it's possible in Konflux, it's this set of orchestration of these builds and tests that are run. There's nothing inherent about Konflux, which means that you shouldn't be producing an artifact that's so big. We can produce large artifacts. We just might not run friend scans on it.
Yeah, it actually makes sense. That's it's basically covering the stuff that is happening beneath, right? So if for example, the Clam AV, it needs to extract the image, so it needs at least 10 gigabytes plus database. So there's probably exceeding limit there for the task. Meaning extending the pipeline run resources wouldn't help, right?
And I was talking with Louis about this the other day as well, and just to explore potential avenues. But if we find that we're in a class of problems where maybe there's many different tasks that need to do this image extraction, and that extraction process is expensive, then we should consider restructuring the task, or creating a new task and deprecating the old ones, which enables this better flow to have a single extraction process and then potentially run different types of scans or whatnot on it. So again, it comes down to a limitation of the task, what we're trying to do, and what the tasks that we have are capable of doing and capable of doing efficiently.
Right. Yeah, I guess this answers my question and helps with my struggle. So thank you very much. I hope the customer will be happy with these answers.
Awesome. Thanks for raising it, Yuri.
Thank you.
That gets us to the end of the agenda. Does anybody have anything ad hoc to bring up? Any announcements or anything? Jeff.
Hey guys, my name's Jeff Young. I work on the OpenShift multiarch team, and I've been asked to take a look at the upstream Konflux and see if we can get it to work in a multiarch cluster. And that's pretty much it. I just want to introduce myself. I don't know if this is the right place to ask dumb questions, if I just go in the Slack channel. I'm just trying to get in the community and get involved. So that's it. Nice meeting you guys.
Nice to meet you too, Jeff. Ryan.
You said you work on the multi-arch team. Are you on Dennis's team?
Yes, I am.
Cool. Nice to meet you.
Yeah, good to meet you.
Jeff, I think we'd love to have you here asking dumb questions. That sounds like a great use of this time.
Okay.
And Slack can always work for fast things, but even better than that, I'd encourage you to use upstream GitHub issues. That
Okay.
way the discussion isn't hidden away. We don't have a public Slack at this time. As soon as somebody comes around for whom it would be best if we had a public Slack, we might move them, but we don't have that yet. So public GitHub's best.
Okay.
Awesome. Thank you.
Yep.
Anybody else? Seeing no other hands, I'm going to end recording. Thanks everybody for coming today. Good discussion.
Bye, guys.
See you.
Thank you.